This video will present solutions to the VCE 2023 Mathematical Methods Written Examination 2, Section A, Questions 1 to 5. Question 1 asks for the amplitude and period of this trigonometric function. Using the fact that the period of such a function is equal to 2 pi divided by the coefficient of x, we know that the period p equals 2 pi on 3. The amplitude of this function will be equal to the magnitude of the coefficient of sine. As this coefficient is negative a half, the amplitude is a half. An alternative method for this question would be to graph y equals f of x and deduce the information required from the properties of the graph, like locating two adjacent turning points. Question 2 asks for the equation of the axis of symmetry of this quadratic function. If we substitute the coefficients of this function into the relationship x equals minus b on 2a, we get x equals minus 2b on 2a, which simplifies to x equals minus b on a, and so the answer is A. If you don't recall the formula for the axis of symmetry, the same information can be obtained by converting the quadratic into turning point form by completing the square. If you have previously created a user-defined function that completes the square on your ClassPad, this would be a chance to use it. I have previously created a user-defined function called CTS on my ClassPad. The function looks like this. If you want to learn more about how to create user-defined functions prior to high-stakes exams, the step-by-step process is demonstrated in a video included in this collection. To use the user-defined function CTS to answer this question, open the ClassPad's main app, bring up the keyboard, and then tap down to see the catalogue of functions. On the right-hand side of the screen, tap down to select user-defined functions. Tap the function required and tap Input. As the function requires just the coefficients of the quadratic function, we enter A, 2b, and c. We will need the variable keyboard to enter these, with each separated by a comma. Tapping Execute, we see the quadratic in turning point form. The 0 of the squared term gives us the axis of symmetry x equals minus b on a, as seen previously. Question 2 gives the domain of two functions and asks about the domain of their sum. For the sum function to be defined, both of the summed parts must be defined, so the domain we require is the intersection of the two domains. This intersection will start at the greater of the two lower bounds and end at the lesser of the two upper bounds. As such, the domain will be between minus 1 and 3, and so the answer is E. Another approach to finding the intersection of two intervals is to use the ClassPad's AND command. In the main app, enter the first interval using inequality symbols found on the Math 3 keyboard. Now call up the AND command. It can be found under Action, Equation, Logic. If you can't recall the location of a less frequently used command like this one, remember that all ClassPad commands can be found in the catalogue, where they are organised alphabetically. Also, if the command is a word, as this one is, you can just type in that word using the ABC keyboard, which is what I'm going to do. Now enter the second interval and press Execute, confirming that our domain is between minus 1 and 3. Question 4 presents us with a set of two equations in terms of the variables x and y. These equations involve a parameter k, and we need to find the value of k for which these equations have infinite solutions. For two linear equations to have infinite solutions, they must be multiples of one another. Looking at the constant terms, as the second equation has a constant term of 0, the only possible multiple of that is 0, meaning that k plus 5 equals 0. This means that k equals minus 5, which is answer B. Another way to approach this question is to convert both equations into gradient-intercept form and then compare their gradients and their y-intercepts. I'm going to do this by entering the first of these equations into my ClassPad and solving it for y in terms of x. As the second equation is similar in structure to the first one, I'm going to copy and paste it by a swipe, drag, drop into a new input line, and then I'm going to edit it as required. Now I have both lines in gradient intercept form, I can equate their gradients with a little more swipe, drag, drop. And then solve this equation for k via the interactive menu. This gives two values of k for which the lines have the same gradient, and so are parallel or coincident, meaning the equation has either infinite or no solutions for these two values. If we substitute the first of these values, k equals -5, into the y-intercept of the first equation, we obtain a y-intercept of 0, which is the same as the y-intercept of the second equation. This means that the two lines share the same y-intercept as well as the same gradient, so they are coincident, and so their equations will have infinite simultaneous solutions. If we repeat this process for the value k equals 4, we see that the first line has a y-intercept of 1 4/5, which is different to the y-intercept of the second line, and so for k equals 4, the lines have the same gradient but a different y-intercept, and so they are parallel, and their equations will have no simultaneous solutions. Based on this analysis, the answer is k equals -5, and not k equals 4, and so answer B, as determined previously. Question 5 asks which of these 5 similar-looking functions has a horizontal tangent at the point 0, 0. Due to their common form x to the power of n, they all pass through the point 0, 0. So the question is, which has a horizontal tangent at that point, i.e., which has a derivative of 0 at that point? To help me understand this question more, I'm going to differentiate the first option. This can also be done on a class pad. As we can see from the derivative expressed in fractional form, at x equals 0, this derivative will not be 0, it will be 1 over 0, which is undefined. Based on this, we can draw the inference that functions of the form x to the power of n will only have a 0 derivative at the point 0, 0 if their exponent is greater than 1. For lesser values of n, the derivative will be of the form 1 over x to the something, which is undefined, not 0, when x equals 0. Based on this realization, an inspection of the 5 possible answers shows that the only one with an exponent greater than 1 is D, y equals x to the power of 4/3, and so D is our answer.